Okay, so here I am in a terminal session, and in the terminal session, let's start by saying pwd, which stands for print working directory, and that allows me to see in which directory I am, and you should be in assignments/week1/C. And in that directory are a whole bunch of files. By the time you look at this, there may actually be even more because we may have created some more exercises. Anyway, what we're going to do is we're going to compile, link, and execute this implementation of the triple nested loop in the file Gemm IJP. And the way we're going to do that is to use the make file that tells us how to do this. And all we do is say make IJP. And what happens then? Well, what happens is that the driver routine gets compiled, our implementation of the IJP loop of matrix multiply gets compiled, some utility routines get compiled, and eventually this gets all linked together into an executable called, driver IJP.x, which then gets executed where I feed in some input data. I pipe that, that's what they call it in Linux. I pipe that through the driver routine, and then the output is put in this particular file right here in subdirectory data in file output IJP. And then here I also automatically print out the end of the file that is created. What is important here is that in this last column all of the numbers are very small because that measures the difference between a reference implementation of matrix multiply and the matrix multiply that you created, and it even for good measure prints out the overall largest difference that was found, and that is found right here, and you want that to be 10 to the minus 12, 20 to the minus 13, something like that, something small. Now, what has happened now is that in the subdirectory data, if you list the contents of that, a new file called output.ijp.m was created. You can say more output data/output, and you can always do autocomplete by hitting the tab key, and that then lists the entire contents of that file. What we find here is a column that indicates the sizes of the matrices that are being tested. We then have the timing and the gigaflops attained by the reference implementation. What a gigaflop is, we'll discuss shortly. And then you have the time for execution of the current implementation, the gigaflops attained by your current implementation, and then the difference between the result when executing the reference implementation and the current implementation. For the moment, I want you to completely ignore what's over here in these columns on the reference. That is none of our concern yet. The important thing is that you roughly got the right answer. Now we're going to plot this data, and to make that convenient we're going to use MATLAB Online. And over here I'm already in a MATLAB Online session. I have carefully maneuvered myself to the right subdirectory. You can see that up here. And in that folder right now there is absolutely nothing. It may be that there are files there, it may not be. Doesn't really matter. What we're going to do is to transfer files from your local computer to MATLAB Online. And to do that, what we do is we open up what is known as a Finder window. We maneuver ourselves to that folder or directory called data, and there we find now that output file that was just created, but also some other files. And what we're going to do is we're going to drag all three of those over. If those files are already over there, you might as well drag them over and refresh them just in case things changed a little bit. So here we go. We highlight them and we drag them over and we plop them into the current folder in MATLAB Online, and when it says uploaded 3 files, we hit OK. So now here we are. We are in MATLAB Online. We can now open up the live script that helps us view the graphs. And let's open that. Double click it. And I'm just going to let you read what's here. What's important is that in the live script there are text boxes, and then there are executable cells. So this grayish cell here with a number in front of it is an executable. What this particular command does is it executes the commands in the file output IJP, which happen to then load the data. So if we say run section, then it executes that. You see that little thing go round and around here. Now we have the data, then here we can test whether there was a problem with the data, whether the accuracy wasn't good enough. You can do that again by saying run section, and if there's no output, then we're good. Finally, we go to the cell that has the commands to plot the data. What those commands exactly are, you can probably guess. So I'm not going to get into the details of that. We can say run section. And when we do that run section, what we get right below it is the graph. Now, you can actually either put the graph to the right, which doesn't really show up all that well. I like having the graph. Let's see, maybe if we move this, there's the graph. Or you can inline the graph so that it comes below the cell that generates it, and I prefer that. So here now we have the graph. What do we see? We have the matrix size along the x-axis, we have the time for execution along the y-axis, and you can sort of eyeball this and see that maybe this is cubic, and indeed if you analyze what the execution time is for a matrix multiply, it is proportional to n cubed. This little bleep right here, let's just not worry about that. Now, we like to look at performance data by examining the rate with which we compute. So go and watch the next video, and then we'll talk about how to plot gigaflops.